It's the Fisher 170 today. This one was brought to me by a buddy who bought it off Facebook. Does not work, so we're going to get into this one and see whether this one is savable or not. Let's check it out. This time I have a Fisher 170. Old AM/FM receiver. This one looks to be in relatively good condition. I'm told it doesn't work. Let's connect it and see what's going on with it. Okay, I have my speakers connected. I'll switch it to the main speakers. And I hear nothing. Stereo light is lighting up, so we know that the tuner is working. But nothing from the speakers. So let's remove the cover. This unit, oh, that screw is loose. Has somebody been into this before? No, they're not 1/4 inch, they're a little bit bigger. Okay, we'll just use a slot screwdriver on this to open it up. This one's loose. This one's tight, so maybe someone's been in here. Maybe they haven't, but we have to remove these 4 screws on the bottom, and then the chassis will slide through. Okay, with the screws removed, the unit lifts out from the front of the cabinet just like this. This unit has several fuses. Let's check to see if the DC fuses are blown. We know the AC fuse has to be working because we've got AC power and the tuner is lighting up, but we don't know, are the DC fuses down here any good? So let's just measure them. Got the meter in continuity mode. That fuse is blown, as is that fuse. So it could be just blown fuses. Could also be burned out output transistors. So before we replace the fuses, let's check the output transistors. Nice thing about this unit being that it's completely removed from the wood cabinet is at the bottom of the circuit board is accessible. So you can go in and check the output transistors for any shorts. Now this unit was brought to me, it was bought off Facebook. The guy that owns it said he paid $40 for it, so we're going to see whether he got a good deal or whether he got ripped off. This unit is built by Hitachi, which was what happened with Fisher when they stopped building them in the States. This is a Japanese-made unit. It was from the Emerson era. So Emerson was, I think, bought out Fisher, and they moved their manufacturing to Japan. They had their units manufactured for them by Hitachi, which actually are not bad units themselves. This is prior to the Sanyo acquisition. So this is midway between, like it'll say, Fisher Radio New York, made in Japan. Because this unit was manufactured for them by Hitachi, but manufactured to Fisher's design and specification. And then the Sanyo units followed this. Some would actually argue that the Hitachi-made units were a better built unit because they were made in Japan than the American-made ones. I'm sitting here. Oh, that's what I was waiting for. We got a test of our emergency alert just came through, but it hasn't shown up on my TV yet. I've been waiting for it to show up on the TVs. This is supposed to interrupt everything. All the TV radio stations are supposed to be there we go.
This message would include instructions to help keep you and your community.
All the radio stations.
Information visit www.
Intelligence
No action is required.
Yeah, all the radio stations are.
www.emergency.
That's all. Oh, now it's come up on the TV now. Yeah, our emergency system just getting tested today. So everything's now is working. My phone went off, my TV come up with the emergency alert, and all the radio stations. That's our excitement for today. So I'll just cancel that out, and now we can continue. Of course, my music in the background continues because that's internet radio, so it doesn't apply to them. All right, let's check for shorts. Emitter to collector. No short. Emitter to collector. No short. No short. Excellent. So we don't have any shorts on here. If we're looking at the meter, we'll check our emitter to base and collector to base. This design uses the quasi-complementary NPN output. So all 4 transistors are identical NPN transistors, and it uses a capacitor in line with the speaker to block the DC voltage that would be present at the junction between the emitter of one transistor and the collector of the other. They typically float at around 24 volts, and the blocking capacitor prevents that from getting to the speaker. Looks like someone's done some board repair down here in the past. As you can see, they've repaired a fracture, maybe at this transistor. They just put jumper wires over top. Let's pop these fuses out and put a couple new ones in and see whether we have any success. First thing, of course, to check is to see how badly these fuses are blown. Are these fuses really blown bad, or are they just kind of like a stress failure? Stress failure could indicate that maybe some speaker lead shorted and drew a little bit too much current, and the fuses did their job and popped before the amplifier itself failed. Typically, if there was a catastrophic failure, we would expect to see these fuses blown black, but as you can see, they're not. If you look down at them, you'll see the wire is fused right there on this one, and this other one here. It doesn't even look like it's broken. Obviously it is somewhere in the end. The wire is shot. But both these fuses are popped, so these are 2 amp fuses, looks like. Another advantage to this design is even if the speaker wire is short, you generally don't blow the transistors, only the fuses. So let's replace the fuses. Try not to knock myself out with the camera. And then we'll plug this unit into the dim bulb tester on reduced current. That way, if there is a failure, it won't do any more damage and shouldn't even blow the fuses because the current will be limited to less than 1 amp. So dim bulb tester, we're plugged in. Speakers are connected. Let's see what happens when we turn on the power. My volume is down to minimum. I don't hear any noises other than volume controls that are noisy. This unit is working. Gotta clean the controls, so let's clean the controls, and then we'll see how it sounds. Then I'll power it up with full power. So I get my neutral. Can's getting kind of empty. Geez, I might actually have to go and buy a new can. Controls are easy to access on this one. They're right down in the front here. Power's off, so I can spray the controls down and give them a good rotation. So likely what happened on this one is either someone just cranked the crap out of it, blew the fuses, or a speaker line got shorted. With the screw terminals on the back of these units, that's very common because they're bare terminals, and most people, a lot of people, yes, most people, don't know anything about trimming the wire so that it's only a small amount of conductor exposed. I'd see people that have 2 inches of copper bared wrapped around the screws, and a bunch of copper hanging off the end of the wire. Just a short circuit waiting to happen back here. Right, just these are not the best of design. So people would have way too much copper exposed, and you'd end up with stray wires, strands, would cause a short, and that's likely what blew those fuses. So get the cleaner into the other controls and we'll get these cleaned. Balance control. And of course the bass treble controls as well. These ones I'm probably going to have to go in and bend the nozzle a bit and spray them in from the bottom because the tops are closed up. So I'm going from the bottom here. I'm just going to twist the end of the nozzle a bit to give me some reverse thrust. Okay, let's try it again. Volume down. I seem to be missing my left channel. Here's the problem with these screw-down terminals. They have a tendency to let the wires go. You kind of have to get the wires in behind there's a washer in behind. And if you don't get the wires in behind there, they generally won't grip that well. But this is just a temporary connection for testing. As you can see, this one's come off. Best way to connect these speakers on terminals like this is to put spade connectors on the end of your wires so that you can just put the spade terminal down and then tighten it down. I was not a big fan of this type of screw terminal.
My old Macintosh is the same.
They did cause lots of headaches though back in the days that they were used. A lot of people blew up equipment because of those bad speaker terminals on the back. This unit's operational. We can give it full power. Throw the switch up. Give it full power and take a listen to it. Remember, I don't have an antenna on here. I put my hand near the antenna. All that noise will go away. Take my finger off the antenna terminal. See, no antenna. So I'm just using myself as an antenna. Anyway, this one's working. So I would say my buddy that bought this one got himself a pretty good score for 40 bucks. And he can certainly get a heck of a lot more than that for it to resell it, because even though This is a Japanese-made version. It's still one of the models that collectors like to get. They have a very warm sound. This is what's called a capacitor output. So these caps here are actually in the audio output circuit. So it gives it a warmer sound. A lot of the early Class A or Class B amplifiers used to use capacitors in the outputs. Use a complementary pair of NPN, 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 NPN capacitor on the output, which means they don't have to have protection circuit, because even if a transistor were to fail, you won't end up with DC to your speakers because the capacitor will block it. The advantage to having a capacitor in the output is it warms the sound up. It's not a perfect amplifier by any stretch of the imagination, but they have a warm sound, which kind of emulates what they were trying to achieve in the day, and that was to get a tube type sound out of a solid state amp. So this is one of the designs that they did to try to emulate the sound of a tube amp using transistors. As you can see, it has a user replaceable fuse on the back, but Fisher, like a lot of other companies of the era, did not trust people. They would have a sticker on the back that says 2 amp fuse, but they knew that people would obviously, they would replace it with something stronger. They would either put a wire across it, or they'd wrap it in tin foil when the fuse blew. So this one has a double fuse system. They stuck another fuse, a pigtail fuse. In this case, it's a 4 amp slow blow fuse. They stuck a 4 amp slow blow fuse right there, so that if the main fuse blew and it was caused by a fault and didn't just blow because of stress, but if something caused that main fuse to blow, such as overloading, I think this has a convenience outlet, maybe I'm wrong, does it? Yeah, it has a convenience outlet on the back here, right? Switched, says 50 watts maximum. People would plug things into this that would draw a lot more power. And because it was wired through the fuse, it would blow the fuse. Sometimes people would tend to put a bigger fuse in. So to make sure that that didn't end up causing more problems, they put a second fuse here. When the owner of it, I was going to say something else, but I will censor myself because I don't want to offend anyone by calling someone a jackass. Okay, I did it. So when the jackass customer wrapped the fuse up with cigarette paper, believe me, I used to see that happen all the time. They'd take their cigarette paper, because it had a silver backing or foil backing, and they would wrap that around a fuse and stick it back in, make the fuse work. Nothing like creating a fire hazard. Perfect fire hazard. Paper, foil-lined paper, so that when the foil gets hot, the paper ignites. But people would do it. Anyway, to prevent that from happening, they put a secondary fuse in there. Anyway, in this case, it was just the 2 DC fuses were popped. Don't know why they failed. They did not fail destructively, so no components damaged. I suspect that the reason that they failed was because frayed wires shorted out. Anyway, this one's all done. The one thing left to do, I heard a little bit of noise when I changed the speaker mode here. I'm just going to spray the speaker switch here with some neutral as well. If I can, my can is almost empty. There we go. There, that's a little better. Okay, time to put this one together. Comes apart as easy as, or goes back together as easy as it came apart. Just slide the back cabinet onto it. I put the screws into the bottom. Whenever I took these apart, whenever I worked on them, I always tried to make it look like they hadn't been worked on. You could always tell when someone worked on one that didn't care, because they wouldn't line up the indentations like this one here. I'd always try to line up the indentations of the bolt so that it didn't look like it had been opened, but that's just me. This one here, you can tell someone didn't care on this one either. It's got a couple of indentations on it. That was always a surefire telltale that someone had been into it. Get one into the shop, right? And first thing someone says is, "Oh, no one's been into this." Like when they volunteer that information, "Oh, no one's worked on this before. You're the first one to touch it." When they said that, you always knew that they were probably not truthful, and that someone else had been into it, namely the customer. Because why else would they say, "Oh, no one's touched this unit. No one's been into it." Then you get into it and you find that, there's wires that have been jumpered over. Well, this one was pretty obvious because it was repaired onto that board. But another telltale was seals broken and so forth. Anyway, this one's all done. An old Fisher 170. To say it's in pretty good shape. Belongs to a buddy of mine. He picked it up on Facebook for $40. And he's asking me, he said, "Did I get ripped off?" No, I think you did okay. You can certainly get more than $40 for this unit now that it's functional. Thanks for watching.